Hello everyone. Let's take a look at the instructions for homework 3. The first thing you'll do is read in the text of the book Moby Dick, which I'll have in Piazza. Then you'll do some pre-processing, tokenize, create a set of unique tokens, and print the number of those. Create a list of important words by removing stop words. Display the number of important words. Create a list of tuples like this, where the first item in the tuple is the word as it appeared in the text, and the second item is the stem. So notice in this homework we're using stemming instead of lemmatization. Then in step 7 you'll create a dictionary where the key is the stem, and the value is going to be a list of words that have that stem. Okay, so you'll iterate over this list you got in 6, and for every stem, if that stem is not in the dictionary, you'll put in an entry with a list of this word, where if that stem is already in the dictionary, then you'll add the word to that list which you've already got going. Print the number of dictionary entries. Look for the longest list, the 25 longest list, and print the stem in the list. And here I give a little hint about sorting a dict by the length of the value field. Step 10 is going to be the most time-consuming probably, and consequently it's worth more points down here. So what we're going to do is write a function to compute edit distance. Edit distance counts the number of changes you'd have to make to transform one word into another. And there are many variations of edit distance. I have a link here to the Levenshtein distance, which is a popular choice. So let's go look at that. Here's that page in Wikipedia. And for the algorithm, you'll go all the way down, skip over the recursive version, and skip down here to the heading Iterative Version with Full Matrix. And here's the algorithm. As you can see, this is very Python looking, so this won't be too hard to implement. And they give some examples of running it. Why is edit distance even a thing? Well, it turns out it's used a lot in spelling correctors and other NLP applications. All right, 2 more steps. We're going to perform part-of-speech tagging on the original text after step 3. And last step is create a dictionary of part-of-speech counts where the key is the part of speech and the value is the number of words with that part of speech, and then print out the dictionary. Let's look at a sample run. Here I am in PyCharm with my sample solution. So I'm going to hit run just so you see how long it takes. This part was very fast. This part, as you can see, took a minute. And let me scroll back up. These numbers and the other output, you don't need to take this as any kind of, ground truth here, but I would expect your numbers to be somewhere in these ranges. Here's my edit distances and the part of speech counts. This is what took a little bit of time because Moby Dick is a really long book if you've ever read it. Not surprisingly, most common part of speech was noun, prepositions, determiners, adjectives, adverbs. That's not surprising because Moby Dick is very descriptive. And in the screenshot that I've got right here, you can't really see, but it drops off precipitously down to a couple of parts of speech with just one. All right, remember we've always got Piazza for any questions that you have.